Today we're looking at complex numbers. We're going to look at how we write the answers in a very particular format, and then how we perform operations with these complex numbers. We'll be adding and subtracting and multiplying, and then even dividing as well. So when we're looking at our complex number, there's a very particular format. We're going to have a real part, which is separated from the imaginary part. So we'll use A to represent the real part. That'll be a real number, whether it's positive or negative or a fraction. That's the real part. And then that's separated from the imaginary part. There's a coefficient on that in front of the I. So we're going to take a look at a few examples here. When we're looking at adding or subtracting these complex numbers, really just combining like terms. So you combine the reals with the reals and the imaginaries with the imaginaries. So I think it helps. I'm going to distribute the negative first before I start combining. So we have a 3 plus 7i, and then minus 6 and minus 5i. So we want to combine the real component with the real component. So 3 take away negative 6. And then the imaginary with the imaginary component. So 7i minus 5i gives us positive 2i. So notice this is the format that we're looking at. This is the A, if you will. Here's the B, which is the coefficient in front of the I. So we always want the real in front and the imaginary in back. Here's another one. Let's take a look at this one here. I have a real of 7. I have a real of 3. Yes, those can be combined, sure. But this imaginary value, this 5 root 2 times I, it looks like it doesn't have anything else to combine with, except that this 18 can be factored and reduced. So that's what we're going to do first before we start combining the imaginary components, because right now it doesn't look like it's an imaginary. So 7 take away 3 is a 4. What do we have left? We have this positive root negative 18, but we want to factor that. So always factor out the negative 1 away from the positive 18, and that, of course, can be factored into 9 times 2. So positive 9, positive 2, and then when we distribute that negative sign there, we have a negative 5 root 2 times I. So we have the real component in front. There's the 4. We're taking the square root of negative 1, which is an undefined value. So that's why we get around this by defining it as I. That's what you see here. Whenever we see the square root of negative 1, we'll replace that with the I instead. So here we have the I. The square root of 9 is 3, and then we still have the root 2. Now, that's not good form. We'll fix that in a moment. But notice now we have two terms that are both imaginaries. Now we can combine them. So this is 3 roots of 2 times I, and we're subtracting 5 roots of 2 times I. So 3 root 2 minus 5 root 2, that gives us negative 2 root 2 of I. So take a look at the format again. Here's your A. Here's the B. That's the coefficient in front of the I. So yeah, it meets the format that we want. So that's adding and subtracting. When we get to multiplying now, you have to be careful here. This thing is undefined, right? So we can't just multiply with it. For example, we can't multiply root negative 1 times root negative 1 as if that would give us a root positive 1. No, that doesn't happen. Because you can't go undefined times undefined and then all of a sudden get a defined result. It doesn't work that way. So again, we have to do this little substitution. We are instead going to replace that root negative 1 with something else. We're defining it as an I. Then, if we have the situation where we're going to go root negative 1 times root negative 1, do your substitution. So that means it's going to be an I times an I, and that's an I squared. Well, how much is I squared? So again, up here in this little box, I had written down that I squared equals negative 1. How did we figure that out? Well, if you take the previous statement and you square both sides, it turns into this. So whenever you see the I squared, you will do another substitution and take that out and put negative 1 in its place. And that's what we see here in this little illustration. If I have an I times an I, that's an I squared. And we'll take that out and replace it with a negative 1. So in this little mini example, root negative 1 times root negative 1, its final answer is negative 1. So let's look at a few more examples here. Okay, here's a root negative 9 times a root negative 36. In doing these problems, again, always factor out the negative 1 away from the positive value. Here's your multiplication dot. Again, factor out the -1 away from the positive value. So we'll take the square root of -1 and really just replace it with the I. That's our substitution. Root 9 is 3. Again, that's bad form. We'll fix it later. Here's another I, and here's a 6. So when we multiply it together, 3 times 6 will give us a coefficient of 18. I times I will give us I squared. And we always do a substitution, replacing that I squared with a -1. So the final answer is -18. All right, that's the concept. Here's another example. Does the square root cancel out? Let's find out. Right, this is what the power of 2 is saying, where you have 2 copies of these. We're multiplying root -50 times root -50, so I'm going to factor out that -1 away from the positive 50 for both of these. Here I'm replacing that root -1 with the I. Root 50 times itself just gives you 50. And I times I is I squared. We replace that I squared with a -1. We're multiplying 50 times a -1. The answer is -50. So, yeah, check that out. The square root cancel out. Here's another case of multiplying. We have a binomial times a binomial, essentially. It's a complex number times a complex number. We still have to FOIL it out like it was a binomial. So, first term times first term is 20. The outer terms, that's a -35i. The inside terms is a positive 12i, and the last times the last. Now be careful of your signs. Positive 3 times a -7, -21, but you have an I times an I, which is an I squared. So we'll have to replace the I squared with a -1, and notice your middle two terms are both imaginary values, and they will combine. So you have the real component of 20 in front. Here you have a -23i in the middle, and then that -21 is being multiplied by a -1, so that'll turn into a positive 21, which means it's going to be added to the 20 in front. So the final result is a real component of 41, and the imaginary component is -23i. So again, notice it fits the pattern. There's your A, there's your B, and there's your I. Let's take a look at, how about number 8? That's a good one. Let's take a look at this one. Again, we have a binomial times a binomial, so we're going to FOIL this out. So first times first, 4 times 2 is 8. Here on the outside, we have a positive 4 times root -9. We'll, of course, have to simplify that in a moment. On the inside terms, we have a positive times a negative. We'll have a coefficient of 2 in front of that root -9. And then last times last, negative times a positive, it's a negative. And root -9 times root -9 is -9. So here in the middle, I know, I should factor out that -1 and take care of it. But they're the same. I'm going to combine them right now. So 4 of those roots minus 2 of those roots gives me 2 of those roots. With a +9 at the end. We can combine those constant terms, so we have a 17 up front. I really should have taken care of that -1 right off the bat. I should have done so. I didn't. There it is. So we end up with, let's see, 17 plus 2 times the I, and the square root of 9 is 3, so we'll have a coefficient of 6 in front of the I. So there's your A and there's your B. So let's talk about division. And in order to divide, we're using this idea that you see down here at the bottom that's talking about these complex conjugates. Now you can see that the way this is explaining is it's explaining it through multiplication, but the point is that if you have two complex numbers where one is the conjugate of the other, meaning it's the same values, you just have differing signs in the middle, and you FOIL that together, the imaginary values go away. That's super helpful for when we're trying to format our problems with division, as you'll see on the next page. So here it is. Let's take a look at 10 and 11. So this is not the standard form. We want a real component in front. We want an imaginary component on the back. What is this component? It's an imaginary component. That's preventing us from having a real form. So what we're going to do is multiply top and bottom by its conjugate. Now, we could actually make it a little more simple here, but to illustrate the point of a conjugate, you always change the sign. So this is a positive 2i, we would use a negative 2i. Now, there is a simpler way to do this, but I'm trying to be consistent with what we're seeing here on number 11, which is a little bit more involved. So notice this is what we call the conjugate. What that means for us is that we need to distribute that negative 2i to this binomial here. Let's see what we get as a result. 8 times that negative 2i is a negative 16i. And then 20i times a negative 2i, that'll give us a negative 40i squared. And on the bottom, 2 times negative 2 is negative 4, and I times I is I squared. And so notice the imaginaries are going to disappear because in each case that I squared is replaced by a negative 1. So negative 16i, that's a negative 1 times a negative 40, so that's a positive 40. And on the bottom you have a negative 4 times a negative 1, so that's a positive 4. Notice we don't have the imaginary on the bottom anymore. That's what the conjugates are doing for us. Now let's divide by 4. So 16i divided by 4 is a negative 4i, and 40 divided by 4 is a positive 10, but that's not the right form. We have to switch those terms around, put the real component in front and the imaginary in the back. So there's the final result. Now we could have set it up slightly differently. So just to kind of expand on this, I'm writing down the original problem again. And what I'm trying to point out here is on the bottom, we only have one term. And notice that's different than number 11. On number 11, you have a complex number. You have 2 terms. So this is our little shortcut, but it only works if you have a single term. And on a single term, really the only issue is the I. So you could just multiply top and bottom by I, and you can see we'll have smaller values, and it'll work out okay. Again, we have to distribute here on the top, so you have an 8i plus 20i squared, and on the bottom you have a coefficient of 2 with an I squared. Again, we're going to replace the I squareds with negative 1s, so you have an 8i minus 20 all over negative 2. And when you do that division, negative 20 divided by negative 2 gives you that 10 that you see in front, and 8i divided by negative 2 gives you that negative 4i that you see in the back. So yeah, you can solve it really 2 different ways with just the I, but that only works if you have a single term. It does not work if you have a double term, a binomial. So that's why I was trying to go through this process at the beginning of showing you this is what the conjugate looks like, because you have to use the conjugate in number 11. I have a binomial, a complex number on the bottom, which means I can't just multiply top and bottom by I. No, we have to use the conjugate. So you change the sign in the middle. So it looks like a 4 plus 3i, and we have to multiply top and bottom by this, which means we're multiplying a complex number times another complex number, so treat it as though you're foiling it out. First term times first term gives us 12. Outermost terms is positive 9i. Inside terms is positive 8i. And the outside terms, the last terms rather, 2 times 6, and then I times I is I squared. Same thing on the bottom. Foil out these 2 complex numbers. So 4 times 4 is 16. The outside terms is a positive 12i. The inside terms is another 12i, but this time it's negative. And finally, now check your signs. It's a negative 3 times a positive 3. That's a negative 9. And then I times I is I squared. So we have to combine these terms in the middle because those are the imaginary components. And then we have to replace the I squared with a negative 1. So we have a 12 in front. Here we have positive 17i. And replacing the I squared with a negative 1 means this is now a negative 6. That's the numerator. On the denominator, you have a 16 in front. Those middle terms cancel out. And then negative 9 times a negative 1 is a positive 9. So let's combine those. real components. So 12 take away 6 gives me a real component of 6 in front with a plus 17i behind that. And on the bottom, 16 plus 9 is 25. So check that out. The imaginary value is gone on the denominator, but it still doesn't meet standard form. We want two separate components. We have to have the real component separated from the imaginary component, and right now they're grouped together because that division bar is a type of grouping symbol. So divide each of those components by 25. That means your real component is 6 over 25. Separated from the imaginary component, which has a coefficient of 17/25 times I. So you can see there's the A, there's the B, and there's the I. So that's the pattern that we're looking for. So there's your final answer. And I'll skip the problems below that. That's just looking at patterns. If you square or cube or raise I to certain powers, we'll just focus on these basic operations.